Hey guys, and welcome to a tutorial, and in this tutorial we will be creating Flappy Bird on the PSP using the QuickGame API, and we will be programming today in C. To get started, first things first, is obviously going to be making a directory. So we're going to make a directory here, and we're going to call it Flappy Bird. Go into Flappy Bird, and we'll do git init. Now that we've initialized our Git repository, we're going to do git some module add, and then we'll need to get the link for QuickGame, which we have here. We're also going to have to do git some module update init recursive to download GU to GL, which we will rely on. We can now open our text editor. I will be using Visual Studio Code, and there we go. We now have QuickGame. We'll also create a terminal here, and we'll use this for the rest of the tutorial. Our first thing here is going to be creating CMake lists. So CMake lists.txt. We'll do CMake minimum required version is 3.17, and project Flappy Bird. Now we'll do set CMake C standard to be 11. We'll do add executable. We'll call it Flappy Bird. Flappy Bird. Then we'll call, and then we'll have main.c be our main file, and we'll create that in a second. We'll then do add subdirectory, and we'll have to add QuickGame as our subdirectory and call it by the name QuickGame. We'll then have to link it, so target link library, Flappy Bird, public QuickGame. So QuickGame will be linked with Flappy Bird. And then we'll also have to include Flappy Bird, public QuickGame /include. And then we'll create our PBP file for the PSP. And our target will be Flappy Bird. Our title will be Flappy Bird PSP. There we go. And then build PRX will be on. And that will be our configuration file. Now for our C file, we'll create main.c, hashtag include quickgame.h for now. We'll create integer main, and at the end we will return 0. We'll create QuickGame. We'll do if QuickGame init is less than 1 or is less than 0. Return 1, so return failure. Otherwise, we'll have QuickGame terminate. And then we'll do while true. Then we'll do a little bit of bookkeeping here. We'll set graphics to 2D. And then while QuickGame is running, we will do our main game loop here. Now let's create a directory here, make dir build, cd into the build directory, do CMake, PSP CMake, ... to get our information here, and if we make, everything should compile here. I missed a parenthesis. There we go. And there we go. So we now have a working build system. What you want to do probably is create git ignore file and ignore the build directory, because that will clutter your directories way too much. There we go, it goes back down to 5. For the assets, I did pack them up, and I include them in a GitHub directory. And I will include this directory in the description. It's QG Flappy Bird PSP, and there's an assets.zip, and you can download that to get all the PSP assets. What we'll do quickly right now is I will reveal this in Explorer, and I will copy over those assets. Inside the assets folder, there's a sprites folder, and this will have all of the sprites for our game. All right, so getting into the very basics of game management here, what we should do is probably create a method for updating the game and a method for drawing the game. Both of them will be used inside of this rendering loop. So we'll create an update and we'll take a double. This double will be called DT, which is short for delta time or the change in time. We'll also have a void draw, and this will handle drawing all of the things to the screen. So we will have update, and then we will have draw in here. To get delta time, we're going to need a timer. So let's go ahead and define a timer object. So it's QG timer. And we'll just call it timer. Then from here, we can do start the timer. So we will do QuickGame timer start. And then we'll pass in a reference to our timer. And then here we will do QuickGame timer delta and pass in the timer. That way we should be able to get our timer value as double DT. Inside of these methods, we'll have to do a few quick housekeeping things. We'll do QuickGame input and then update. So we can update and read keys. And then here in the draw, do QuickGame graphics start frame. And then we will do QuickGame graphics clear, and then QuickGame graphics end frame. And all this will do is do our basic render loop. Cool, now I'll create a method here called load sprites, and this will actually be loading all of our sprites. Theoretically, we should also do unload sprites, but for the context of this game, we're not really ever switching to scenery, so just loading the sprites once is probably fine, and you don't really necessarily need to worry about deallocating them because our game is just too simple to deal with that. So we can use contain sprites here. So first things first, we're going to create some base sprites that we'll need for our game. So we'll need QG sprite T. This is our sprite pointer, and we'll use the background, we'll have a base, game over, and we'll need the pipes. Now we'll also need arrays of sprites, so we'll do the score. So the score is going to be the numbers 0 through 9, and then we'll also have the bird itself, which will have 3 frames. It has a flap up, an idle, and a flap down. So to load sprites, pretty much all we need to do is we need to say that our background is equal to QuickGame sprite create contained, so we'll be creating a contained sprite. So then we will set the initial position for the background, 240, and then it should be basically in the middle, but we need to offset it a little. So 120 plus 64, which is also 192. So we can say 192 here. And then it's a 512 by 512. The actual resolution is 256 by 256, but to match with the rest of the game, it has to be scaled to 2 times. And then we'll have our background texture information. Our background texture information will be QG text info, BG text info, and then we will say the file name. So the file name is assets, sprites, background.png. Do we need to flip it? Yes, all of these will need to be flipped, and VRAM can be set to 0. Technically, we don't need to leave this in. It will be set to 0 by default anyways, but it's better to be more explicit about it. So that will load the background. The second one that we'll do is the base. So we can do this again, but we'll call it base text info. And then the sprite here will be base, and base.png, or actually it's called slide.png. I forgot I renamed it. And that will be the 2 things for the actual foreground, background of our scenery. To draw this, the first thing that we'll be drawing is the background. So QuickGame sprite draw, and then we'll draw the background. And then we will create a method here called draw base scroll. So void draw base scroll. And what we're going to use is we're going to have to include hashtag include GU to GL, and this will give us a little bit more power over the rendering. Let's see, the information here needs to also be changed. I forgot to do that. So it's 240 and 16 at the bottom of the screen. The size is 256 by 64. Now 256 is not going to fully load to the entire 480 pixels on our screen. So what we're going to have to do is that we're going to have to position them. So we'll have to basically render the thing twice. So first thing, we'll have base, and we'll use the transform inside of it to set the position.x equal to 128. And then we'll do again, we'll say it's 384. And these will be equidistantly separated from each other by 256 units. In this case, 256 units is 256 pixels. So QuickGame sprite draw, and we'll draw the base. And then we'll draw the base over here. So now we have the draw base scroll. Well, we're not quite doing the scroll yet, but I can go ahead and do a make here. End frame needs a boolean inside of it. This boolean controls whether or not it's vsynced. We do want vsync, so we're going to hit true. And of course, before we call that, we're going to be calling load sprites here, just to make sure that our sprites will actually be loaded. If I then run it, we can see that we have our base down here alongside with our Flappy Bird background. Now to make it scroll, we can use the thing called the texture offset. So we can do GL text offset, and we're going to only offset the X because we want it to scroll left and right. So in this case, we want it to scroll to the left. So what we can do is that we'll do timer.total times 0.5f. So it'll move at basically half the speed per second. And then we'll set it back to 0 over here, just so that the rest of everything else on the screen doesn't scroll as well. And we go ahead and run it. We can see that our bottom is now scrolling. All right, so we have the background, and then we have the actual base scrolling mechanism. So now the next thing that we're going to do is we're going to be using the bird. So to deal with the bird, we're going to go ahead and load up our bird, and then we will set the bird information 1, say bird over here, bird 0, equal to the, we'll put it at 160, so it's going to be to the left side of the screen, 136 directly in the middle. And then the size of the bird is 64 by 32. And then its B1 is going to be our texture information. So we're going to go sprites, bird, and then we will do, the first one will be the down PNG. That'll be bird 0. Then bird 1 is going to be the idle. And then the last one will be the up. Oops. Up B3, bird at position 2. We'll also do a quick for loop here for integer I equals 0, I is less than 3, and I plus plus. We'll also go ahead and look at bird, and then inside the bird we want to set the actual size of the hitbox to equal to 32, and I believe this is 20. And the reason we're setting this here is because if you look at the bird PNG, you can notice that there's quite a bit of extraneous space here that you don't really need. So you can actually shorten down this to be like that. In fact, we could probably even go to like 28 or so for the X size because it's a little bit larger than life. All right, now we have all three phases of the bird. We're gonna actually draw the bird, and the bird has to be above the scrolling base. So we'll do QuickGame sprite draw, and we'll do the bird, but bird is an array, so bird has 3 different stages. To do the animations here, we can actually create a simple system for the bird animations. We'll have an integer which tracks our current animation number, so it will start at 0, and the floating point for the animation time is 0.0f. What we'll do is we'll create a method here called flap wings. So this will do the automatic animation, double DT. Animation time is added for the delta time between each frame. Then if the animation time is greater than 0.125, which is 8 times per second, so we'll change 8 times per second. So the current animation increases and animation time gets reset. So this will always just increment every 8 times per second the animation frame. However, if the current animation is 3 or higher, but in this case it can never be higher, current animation will become 0, so we'll reset to the beginning. So we can then do this in update, where we have the delta time, and we can do flap wings in delta time. And here we'll do current animation as our sprite draw. And as you can see, we now have our bird, which is flapping its wings. All right, so in order to actually make the bird bounce up and down, we're gonna need a little bit more information about the state of the game. See, because if you normally start the game, the bird just like flies there until you actually hit the jump button or the flap button, whatever you want to call it. So we'll need a Boolean state for that. So we'll have game state. So we'll have a Boolean for started, and we'll have a Boolean for dead or the end, basically. And then we'll also have the bird data. So the bird needs to have a position, bird y, and it will also have a velocity. Now inside of the update, we're going to say if we're not dead, we're going to do this code. Otherwise, we'll do some other code. And then while we're doing this, we'll do flap wings. Put that there, and then we'll do a method for updating the animation of the bird based upon when we actually do the flapping code. And we'll go ahead and do if QuickGame button pressed PSP control cross. This will say that we started the game, and this will also say that the velocity of y is equal to positive 192, which will cause us to jump. Also check that we have PSP control included here, so we can use PSP control cross. We'll also do an if started, and then we'll say velocity of y is minus equal 512 pixels times delta time. And then we'll say that the bird y is equal to, or is added to the velocity y times delta time as well. Which is all great, but now we need to actually have something that sets up our data here to be valid. So we'll do void reset game, and what the reset game will do, we'll say the started is false, dead is false, and then we'll also say the bird y is equal to 136, and the velocity y is equal to 0. That's our base data here, and we're going to have to go ahead and slot that in to here. Reset the game, and now this method that I mentioned, animation update, we'll also need to create it. So animation update will basically handle the state of our bird. So bird at current animation transform position y has to equal to the current bird y. So wherever the bird is on the screen. Then if velocity y is less than negative 20, else if velocity y is greater than or equal to negative 20 and is less than or equal to 20, and then else if velocity y is greater than 20. And what this is going to be used for is actually maintaining the current rotation of the bird. So current animation transform rotation, for example, will be 30 here, and then we'll do flat here, so 0, and then negative 30 if the velocity is, or sorry, I've messed this up. It's negative if the velocity is negative, and it's positive if the velocity is positive. So that should handle that. And if we go ahead and start our game now, see flap wings. Oh, I forgot to insert DT here. Now if we run the game, we see the bird here. We hit the cross, we jump up, and as expected, our bird looks up when we are flying upwards, and our bird looks downwards when we're flying downwards. Now there is a problem, because if you crash into the ground, you should die, but otherwise here we can actually just fly above it. So in order to fix that, we're going to add the sort of game over and respawn system. So if we've started the game and the bird y is below a certain value, for example, if bird y is less than 48, we're going to say that we died. And then what we're going to do inside of our death is number one, we're going to reset the timer. Oops, quick game timer reset, and then we'll do our timer. And what this will do is that inadvertently will also stop us from having the scrolling effect from draw base scroll down here, because the timer will no longer be ticking. And then we'll be polling, so if quick game button pressed, PSP control cross again, we'll reset the game. And this will start our game all over again. Now for drawing, all we need to do here is say that if the state is dead, we will draw our sprite draw. We will draw our game over screen. So to get the great game over screen, we'll do this again. And game over will be /assets sprites, and then it's called game over.png. We'll locate that at 240 and 136, so roughly the middle of the screen, and it will be 256 by 64, and then we'll call this game over information, and it will be assigned to game over. So now we'll load the game over, and then we will draw it if we die. Now if we do this, if we fall below this, we hit the game over screen. And what we can do now from the game over screen is hit the cross button again, and we're reset back to the beginning of the game. So now you have like basically the core mechanic of Flappy Bird here, which is you're able to jump and go around. So the next thing, of course, is going to be the pipes. For the pipes, we already have the pipe sprite, but what we will need to do is define some basic information about where the pipes are on the screen. So what we'll do is we'll create a structure that shows us what a pipe is. So we'll have a type def struct. We'll have a float x and y, and then we'll have a boolean for active, whether or not that sprite is active. So pipe information, and then we'll have pipe info, pipes, and it will be 3. We'll have 3 of them. So now when we reset the game, what we'll do is we'll have 4, integer I is 0, I is less than 3, and I plus plus. Pipes at I is going to have an x equal to 512, so that will be off the screen, plus basically we have an offset here. They're roughly spaced 192 pixels apart, so 192 times I. And then we can do pipes, oops, this should be pipes as well. Pipes I.y equal to 96. That's like the base floor that we can put it at. And then we'll do plus 192, or plus a random number modulated by 128. So this will be a random number between 96 and 128. What this will allow us to do is we'll position it on the screen. And then, of course, that pipe will be active. So inactive sprites, or inactive pipes, are the ones that will be behind the player. So if you've passed through the pipe, you will no longer be able to collide with it, and you can't trigger anything there. Obviously, now we also need to manage the pipes in our game state. So if we started the game, we're going to have for int I equals 0, I is less than 3, and I plus plus. And we'll have pipes at I.x minus equals 128 times dt. So we'll move that many pixels per second. And then if pipes at I.x is less than 160 and pipes at I is active, it will no longer be active. And this is where we'll actually increase our score, and I'll deal with the scoring system later. To do increase score. Then if pipes.i.x is less than negative 32, it has to be negative 32 because the pipes are 64 wide, so halfway through is 32. So once it's completely off the screen, now we can reset that pipe. So what we'll do is pipes at i.x plus equals to 512, and we'll do pipes at i.y equals 96, or sorry, this will be 576. Then we'll do 96 plus rand mod 128. Same way we do the other one, and then this will become active again. So that way we now have pipes respawning once you've passed through them. Now, of course, we've got to actually draw the pipes on the screen, so I'd recommend creating a method for this. So I'll create it under the update and we'll call it void draw pipes. Once again, we'll do the for loop and I equals 0, I is less than 3, and then I plus plus, and then we'll do pipe. So the transform position x is equal to pipes at I dot x. And we'll do the pipes position dot y. Now the y has to be a bit offset, so we're gonna have to do minus 128 to get to the center of it, and then minus 40 for the gap between it. So we'll have roughly an 80 pixel gap between the two. We'll also make sure that the transform rotation is equal to 0 because we will modify that in the future. So QuickGame sprite draw, and we'll do pipe. And then we'll do basically the exact same thing, but we'll do the opposite. So this will be plus 128 plus 40. The rotation will then be 180 degrees, and that will draw the pipe on the other side. Now, because our collisions are sprite-based, we can do the following. We'll do QuickGame sprite intersects, and we'll do pipe and the bird at the current animation. And then if this actually happens, we will set dead to be true. And we'll do it again on the second rotation so that both sides will be hit with dead. Last thing to do now is to do draw pipes inside of the method here, and it has to be before the base. Otherwise, you'll have these weird pipes that'll go over it. We'll also need to make sure that we load our pipe into the game. So we'll do QG texture information. Will be pipe information, file name equals assets, sprites, pipe.png, and then flip is true, VRAM equals 0, and then pipe equals QuickGame sprite create contained, and then our initial position here is just 0, 0, and we'll do 64 by 256, and it will have the pipe information. Theoretically, I've covered everything for pipes here. Implicit definition of rand, right, so we'll have to include stdlib.h, and to do, to truly randomize it, we'll also include time. So we'll include time.h. And then what we'll do here is, before we actually play the game, we'll do seed rand from time at null, and that will make sure that it's different every single time we play the game. All right, and if we run that, when we start, we see these pipes that show up. We can go through them, and if we actually hit them, we get game overed. This is pretty much the base of actually how Flappy Bird works. As you can see, this is a low example of how the pipes will spawn near the ground, and if we go through it, we can keep maintaining this until we hit something. So if we hit the pipe, the game is over. The last thing that we have to do here is actually tracking the score. So we'll just have an integer that tracks our score. So score, integer, current score. Current score will be set equal to 0. And that's that. Now, once we pass through these, we'll increase the score, so current score plus plus. And this is what we've actually been using this score thing here to represent. This is what we have the score sprites to represent. Now, to load the score sprites, what we're going to do is we're going to do for int I equals 0, I is less than 10, and I plus plus. So we'll iterate over all 10 of the values. We're going to need stdio for this, so we'll do hashtag include standard input output, and we'll go to here, and we'll just create a buffer here for our file name, and we'll print to the buffer. So what we'll do is we'll sprintf. So sprintf will print to this buffer, and we'll do /assets/sprites /count, and then it will be the number.png, and then we'll just pass in the number. We'll create a texture information object for each file, so we'll do file name, And then flip is true, and VRAM is false. Boom. And then what we can do is do score at I equals QuickGame sprite crate contained. And then we will just do it 240, 136, and it will be 32 by 64 as the size. And we'll include this information. So we should be able to load all of the score information up there. To draw it onto the screen becomes a little bit more complicated. So we will create a method here, and we will call it draw score. Drawing the score should happen pretty much as a top level UI, so we'll do it here, and then we'll call it draw score. And then here we'll do void draw score. So in order to draw the current score, we need to know the number of digits in our score. So we'll create a sacrificial variable called s for score. We'll call it current score. We'll have the number of digits is equal to 0, and then while s is greater than 0, what we'll do is we'll do s divided by equal 10, which is plus plus. So for every tens place, we'll get another, we will have more in this score. So until s becomes 0, that means we'll iterate through all of the digits. And we can actually set g equals 0, because something could end with 0. Next, we'll create an offset variable, and we'll use this offset in order to figure out where the text should be positioned on the screen. So we'll create an x offset, and this will be equal to float of digits minus 1. So if we only have one digit, there's no reason to move it because it will already be centered. And then we will have that divided by 2. That way it's like the actual center position of it. And then it has to be negative because we're going to be trying to get the x offset to be the furthest on the left. So then we have to do x offset times equals 24, which is going to be our spacing that we use. Once again, this is being used because these PNGs do not necessarily, they have a little bit of buffer space on each side, so you got to count differently. Once we've created this offset, we'll create another offset variable here, which will be the current position. Then we will do while, we'll set s equal to the current score. And we'll have to do the same thing again. We have to actually draw this from right to left, by the way, because this is the only way we can get the digits. So integer c will be our individual number from 0 to 10, so s mod 10, and then s gets divided again by 10. This will be g equal. And then we'll do score at c. We'll set the transform, position x equal to the negative x offset plus 240 minus the x, the second offset. And we'll do score at c. Oops. Score at c. Transform, position y is equal to 192. We'll do xn plus equals 24 because that's our scale. Then we'll do QuickGame sprite draw. And we'll do it at score c. My bad, these actually can't be less than equal, it has to be less than for this to work properly. Now if we go ahead and execute it, we can go ahead and see that as soon as we pass the first, oops, I died instantly. Okay. Once we pass the first one, we get 1, 2, 3, 4, I get to 10, 6, 7, 8. Oh, I clipped the very top of it. And there, as we can see, you can get to the double digits and it works perfectly. And that's pretty much it. Congratulations. We now have a fully working copy of Flappy Bird written in exactly 250 lines of C code. Thank you guys for watching. Have a great day. And the source code is in the description for you to check out as well.